Okay, so let's start. Our next talk is coming from TrustInSoft. Our speakers today are Mr. Rolland Dudemaine. Rolland has been active in the embedded software industry for more than 25 years. He has focused on low-level software, including high-performance, safety and security-related RTOS in all aspects of the platform, from development to safety and cybersecurity. And then we have Mr. Laurent Maillard. Laurent is a seasoned business development executive in the software, telecommunication, and space industries. Among other projects in the space domain, he has been involved in the development of the constellation of broadband satellites, Skybridge, the ground station of Galileo search and rescue, or numerous Earth observation applications. So, thank you, Laurent and Rolland. The stage is yours.
Okay, thank you for being here today and to listen to you. So the idea today is to introduce our solution, TrustInSoft Analyzer. TrustInSoft Analyzer has a unique value. It's a sound solution. We'll come back later on about the meaning of sound with the help of Rolland.
We're not talking about sound in space.
Okay. Let's start to introduce ourselves. So look at these pictures. You see 6 pictures, 6 objects, very well-known objects. First of them is a Sony PlayStation. You have a Google Pixel phone. You have a Mustang Ford electric vehicle. You have a submarine, a space rocket, and a plane, A380. So I would ask, what is the common point with these objects? I guess you know. They are all using our solution, TrustInSoft Analyzer, built for safety and mainly used in this case for security purpose. Let's... okay, just a short overview about our company. We celebrate yesterday our 12 years, so we are a 12 years old company. We are based in Paris. The purpose of our company is to propose solutions for security for C, C++, and Rust software. Our value proposition is twofold. On one hand, we can propose a product, the TrustInSoft Analyzer. It's an hybrid solution based on formal method who can help you to find vulnerabilities. And on the other hand, we can propose a service solution with experts to help you to do validation and verification. Our product today is dedicated mainly for critical system, mainly in 2 industries, automotive and aerospace and defense.
Even though we were showing mobile before, that's also... They also do critical stuff from a security perspective.
Exactly. Let's go deep in the context. In fact, if we look at software now for space system, we've seen that the cost of software in space system development has been increasing significantly over the past decade. This growth reflects the expanding role and complexity of software in modern space systems. So if we compare with the early stage of space in the 60s, a program used to have something like thousands of code. It's not anymore the case. We are talking about millions of codes. This is the case, for example, for the mission, the Mars rover Perseverance, which used something like 2 million of codes. So the complexity is everywhere, and in terms of cost, the ratio is not anymore the same. Today, we can reach the size of 50 to 70% of the overall cost of the system development. So software is key, and the cost is growing year by year. So we try to consider that, and with the help of our tool, we can help to find software issues, and we will explain that with Rolland and show a use case that we've done.
So what's interesting to observe is that, well, it's not a drill. 2 years ago, in this event, Tele showed hacking of a satellite. But there's not just that. It wasn't just a proof of concept. You have real life examples already there. And then we can explain those. Specifically, we're going to focus on code that is considered mission critical here and deployed. So Ariane 5 is an obvious example. You can find many videos on it. After 40 seconds after launch, in one instances of the launches, it exploded. Cost 400 million. And after the fact, the original issue that led to that was a signed integer overflow. It's one kind of a runtime error. Could you test for that? Partially yes, partially no. There's a discussion around that. Another example, which is much less known, but that can have a wide impact as well, and it had a wide impact. GPS, as a constellation, maintains a very precise date or time. However, in the encoding in the protocol, to get that time, the weak number is encoded only on 10 bits. That means every 19.7 years, it overflows. And as it turned out, in 2019, that was the first overflow, and some of the receivers actually malfunctioned because of that overflow. And that was observable in the field. So that wasn't the satellite system that malfunctioned, but the receivers. Because, again, space is not just things in space. And another one which you may discard because, yeah, it's Windows, nobody trusts Windows, but actually it's mission critical. And when it comes to be yet another integer overflow or yet another runtime error inside the Windows kernel, and that one actually, if you want to look it up, I don't want to write all the details, was actually published as a CVE because it was actually something exploitable. That's the big problem. That means someone could actually gain system-level privilege and go into that and exploit the entire system. Again, you have ground system that may run Windows. And that happens with Linux as well. It's not a discussion. If you look a little more generic, in a generic way, when a lot of those systems are programmed in C and C++, and if you look at studies from neutral entities like Mitra, which we hope will continue to live for a long time, their reports is, so if you don't know Mitra, they have CVEs, vulnerabilities, which are published, and they have CWEs, which are weaknesses. What are the issues behind those vulnerabilities? And when they list the vulnerabilities, the weaknesses by category, what you can observe is that actually about 70% of those are actually runtime errors, not bad configuration or supply chain attacks. Those exist. Previous presentation explained that. But in the end, the majority of those remain programming errors. Some of those you can test for, functionally test for, and then there are the runtime errors, which remain the majority. What are they? They're memory safety issues, so buffer overflow is the typical one. Incorrect pointer handling and incorrect memory accesses is another one. But I gave example of also computation overflow, which you may think is actually fine and benign, but sometimes not. And those are the surface bugs. When you look at it from, we're at CYSAT, so when you look at it from a cybersecurity perspective, it becomes even more interesting. So you have the initial bug, which may or may not be something directly exploitable, but usually once you found a bug, you can divert the execution flow, and then the second stage, the second bug that will actually allow you to run arbitrary code is always a runtime error. It's always something that will actually allow you to completely derail the execution and lead to something that you can drive. So in a way, if you manage to remove all those runtime errors, maybe it wouldn't prevent the explosion of a rocket, but it would actually prevent a voluntary exploitation of it. And that's a big thing. And so, well, again, let's stick to reality. So one of the projects that we've had the chance to work on is with NASA. They have an executive called the CFE, Core Flight Executive, that they actually made open source, and that one is actually it's been used for more than a decade, right? In the James Webb Telescope.
Plenty of missions for decades.
Yeah. And so it's being used in multiple projects. So what's interesting is they decided to open source it with the perspective that they still want to maintain a critically high quality, but they still allow others to look into it. But we worked with them directly. And so spending a few days together on that system and running it with our tool, what you can see is actually the real analysis there. It's not a complete analysis because we didn't have the chance to finish the work, just make an initial analysis there, is that we could find it's about 100K lines, C lines of code. And you would think that because it's already been shipping it out there, most of those bugs would have been removed, and it wasn't the case. It was a surprise to everyone. We found 2 cases of reading an initialized memory. We found 1 case of another signed integer overflow, and actually one that really truly surprised them is a null pointer dereferencing. Well, it was in a test, not in production code, but still. And if you don't trust me, actually don't trust me, go to the GitHub project. You'll find the details about those issues visible there. If we go in the details, and I hope you can read there, I don't know if it's readable enough from back there, but the point is really that the tool was able to understand the behavior of the software. Here, what happens is there's a read operation from file system, because there's the concept of that file system in that deployed runtime, which is a specific one, but still. And file system read can succeed or fail. And they didn't check for failure. Typical programming error. But the result is that if that failed, then the access could have been uninitialized, and then that would lead into something really bad. And the question I would ask to you is, what kind of tool do you use today to verify that kind of mistake, which is not visible? Because it's really error checking if you think about it. But you need a tool that understands the context of your execution. Another one, which again could look benign at first sight, but can have disastrous consequences, is signed overflow. So that's in the time management. Here you see the 2 lines of code where it's a typical code to encode the time and change and convert from one format to another. Again, nothing horribly out of the ordinary. But the C and C++ language being what they are, when you cast and shift that value for 24 bits, then actually, because the base value was 1 byte, then it may become something, it will be cast to a signed int, and then that means after a couple of years, you will have an overflow. Is that good or bad? Well, actually, in that particular case, that could lead to computing a bad time. Again, not always a big problem at the beginning, but that could lead into saying that a crypto key is valid where it's not, and then, boom, you have an exploit. So again, the perspective there is to see, to find all those things. How do you test for that? Well, again, it's not specifically code that, as a human, you would say is bad. So you need a tool to tell you that. You have coding standards, but even those coding standards do not always help you there. So you need a tool that actually understands the behavior of the software and understands if that's reachable. And that's exactly what our tool does. So Laurent mentioned soundness earlier. Again, no sound in space, but soundness is actually a property of a tool that is able to claim that everything it searches for will be found. And that means a sound tool will actually tell you if you have done enough work of giving me enough input or configuring enough, and there is no alarm raised, then the tool will assert there's no bug anymore. And so the TrustInSoft Analyzer tool is one of those such tools. That's why it's based on formal methods to be able to reach that statement. And we pass standard test suites from NIST. So if you, for the expert, it's Juliet and 85. And we pass more than that, of course. And what's interesting is, well, that works for C, C++, and Rust. And it's also safety certified as well. And, well, then that's just scratching the surface because the tool understands the behavior of your code, then it can give you coverage information, which most tools don't. Static analysis tools don't. It will also, there's what you see as a screenshot here, is some kind of, I call that a multiverse debugger, where you can explore everything that's been seen by the tool, all the values, interactively, without the need for the real target. So that means that if you have a simulation environment, you don't even need that simulation environment, the tool will actually provide that. Originally, we developed that tool, the founder of our company actually developed that tool with the perspective to find all what is called undefined behavior in C and C++. But actually, Rust is coming. And some people might say, well, Rust eliminates the problem. Actually, no. Rust goes very much in the right direction. And actually, what I really love about Rust is it took a lot of industrial lessons. It took a lot from Ada, it took a lot from C and C++, took a lot from many languages. But in reality, it has the same drawback as all those languages which don't have, which define everything, where there is no undefined behavior, is there are things that the tool can predict, and it will give you a lot of issues in the first place when you compile, and that's great. But there are shortcomings. The biggest one is the first one, and the rest I won't have time to talk about. It's really when the tool cannot figure out things at compilation time, it will instrument the code to check it at runtime. And when the runtime check fails, then it causes panic. So it's still a runtime error. You still have runtime errors. And in space or in mission critical, you don't want that. So you still need tools to be able to detect that ahead of time. And then, of course, that's all good if you do only Rust. But nobody does that. You always have libraries in other languages. And so that's where TrustInSoft actually manages to do the analysis across Rust and C and C++ language at the same time. So again, you need to experience it to understand really what it can bring you, but there you go.
What we have seen, runtime error are the critical issues that you need to solve. It's usually more than 50% of the vulnerabilities that can be found. It's not possible to find with all the tools. TrustInSoft is the solution to find and to answer to this problematic. And that's all.
Yeah. Well, so, yeah. Any question?
Okay, thank you very much for the presentation. So, is there any questions from the audience? Yes.
Thanks. So what is the technology you're using behind the scene? Like formal methods, fuzzing, mix of both, or?
So that's a great question. The core of the tool, and actually the founders of the company, worked on Framacy. And what Framacy brings is a framework to analyze the code. The Framacy takes the perspective that it will basically match the code and a specification of the code with the demonstration that, okay, demonstration matches the spec. Our tool actually loses the spec, doesn't require the spec, because and it takes the perspective that even if you want to prove some code, you still have to have no undefined behavior in the code, because if you do, then the proof means nothing. So in the first place, what they observed, and we still observe in the field, is that most people want to make robust code, and they don't care so much about proving the code because they can functionally test and they consider, for the most part, that this is sufficient. So what we provide there is a tool where you can functionally test on the hardware or with the tool, and you can ensure that there is no runtime error. And for that, you don't need a model. You don't need a spec, just the code.
Thanks.
But it's the same engine.
Okay. Is there any other question?
No.
Okay, go.
What are your thoughts about design by contract, which is quite new, arriving in C++ 23, and that could help that kind of tools?
I think, again, when you have the luxury to only use code that didn't exist, that you create yourself, that's the right way. If you reuse code, what do you do?
Then I have a question myself.
Mm-hmm.
It's actually an interesting choice that you have been looking into Rust as well. For us as a cybersecurity company, we have been pushing to use Rust on board, but we noticed that it's not that such a common choice for onboard software. So what is your position regarding this?
I don't know if you want to answer that.
I don't know. So today we involve in the foundation of Rust. We partner with Ferrous, and one of our biggest customers is pushing for us to work in that domain. So that's why we are there. But
Yeah.
maybe Rolland, you can.
Yeah. So outside of the specific space or aerospace industry, Rust is already there in mission critical systems, including security critical systems. We have customers in the crypto area. We have customers in the consumer is another one. Some make the choice to go full speed on Rust. Some make the choice to still wait for some time. In the wide aerospace, what we see is there's interest for the language, and there's interest to replace Ada also.
Yes. Because from our side, for the space domain, at least for satellites, we noticed that people are not willing to adopt Rust. For now, we hope that things will change in the future, but
it's at the same time very fast to change and very slow to change.
True, that's true. Okay. Sorry.
How long it takes to run your tools for, I don't know, 100K of code? Just to have a...
Does it say the time here? Oh, it doesn't.
Figures about the performance?
So the general runtime, what we tell our customers is that if an analysis takes more than 15 minutes on a particular configuration, then there's probably something wrong going on. The longest one I've ever experienced was a gigantic C++ piece of code, and that was about 1 hour and 30 minutes, but that was really huge. And that one, that one, actually, I could run on my PC in 10 minutes. Well, what I'm showing you. Oh, it's not sharing anymore. Well, the one I was showing, the screenshot of the NASA one.
Okay, so maybe a last question from my side.
Sure.
What's next? Because now we see the analyzer is doing a great job, like analyzing all the vulnerabilities. But, you know, now we talk a lot about AI, how to integrate AI to make proactive recommendation, for instance. Is it something that is on your roadmap?
Definitely.
Sorry, we try to automate our solution. So as everybody, we look at AI every day.
Yeah, it's basically it depends on the perspective to use the tool. If you use the tool for functional specification, you need to link to requirements, and that's difficult to do with AI. You can. If the perspective is cybersecurity, then throw it all, and then AI is great.
Yes.
And yes, we have customers working on that or working with that with our tool. Yes.
Okay.
It looks to be a standalone tools,
Yes.
but it's quite easy to integrate it in a DevSecOps pipeline.
Yes.
Yeah. Yeah, you can use Jenkins and.
Okay.
Yeah, no problem.
Perfect.
It's a fun question for us because the original version of the tool was only come online, and we added a user interface because people wanted the user interface. So for us, it's an easy yes.
Okay, perfect. So thank you very much,
Thank you
Laurent,
very much.
Rolland.